We'll see why security is important in the cloud in the first place. Then we'll see how Google approaches security. Oh, by the way, I forgot to introduce myself. I'm Sakshi. I'm a security specialist at Google Cloud. So we'll start with why security in the cloud is important in the first place. Then we'll see how Google thinks about security and how that approach makes a lot of things different. And finally, time permitting, we'll also see how security intersects with some of our other focus areas, which is artificial intelligence. And no presentation nowadays is complete without discussing artificial intelligence. So why is cloud security important in the first place? Firstly, our region, which is Asia Pacific, has tremendous digital capabilities. But still, it continues to be one of the most vulnerable regions in the world. We have the largest number of global internet users, but we also see more cyber attacks than any other region. And some of the sub-regions and some of the sectors are very new to their cybersecurity maturity journey. But what is most alarming is we have the longest dwell times amongst all regions. So a dwell time is essentially the time when an attacker intrudes your network till the time he's discovered. So if he's intruded your network, that means all the security investments that you've made have already been breached. And we found that amongst all the regions in Asia Pacific, this dwell time was 33 days before we even get to know that an intrusion has occurred. Obviously, we cannot respond to something if we don't know if it has occurred. So this is really alarming. Similarly, cybersecurity skill gap is a problem everywhere. It's a global issue, but it's more defined in our region again. Our region also has significant geopolitical issues, and that ties directly with cyber warfare. And finally, the big four APTs. An APT is an advanced persistent threat. So these are state-sponsored threat actors. The top four APTs in the world find their home in Asia Pacific. So security in this region is super important. Here's an interesting quote by Milind Goviker. He's a distinguished VP at Gartner. And he says that there is no business strategy without a cloud strategy. Gartner says that by 2025, 95% of all new digital workloads will find their homes in cloud-native platforms. Now, if that is true, then an insecure cloud translates to an insecure business, because cloud then becomes an underpinnings of all the businesses out there. Cloud is at the core of digital transformation, and it's crucial to keep the cloud safe in order to keep the business safe. So what are some of the use cases that customers use cloud for? The most digitally transformed customers use cloud to more than just host their infrastructure. They use cloud to build their digital offerings, so build their softwares, their super apps, their e-commerce websites, etc. So the entire process of development, build, and deployment of their application takes place on the cloud. Similarly, customers use cloud to interconnect with their partners, their suppliers, their vendors through APIs. And lastly, of course, customers use cloud to serve their end users. So security has to cut across all these fours. It cannot solely be focused on infrastructure. We'll go through each one of these one by one, and we'll see with real-life examples what can happen if any of these go wrong, how it can have consequences on the customer, on the organization, as well as some of the capabilities that Google has in this area. We'll also see how Google stands in the market in these areas through some third-party market and analyst reports. So let's start with infrastructure. Cyber attack on infrastructure can lead to operational disruptions. They can bring businesses to a standstill. And in some cases, they can also lead to data losses. So organizations need to think about, how do I protect my applications from DDoS attacks? How do I protect my applications from app-based attacks? Just a few months ago, a cloud-based attack led to outages in email and storage systems. These things today, like email, storage, they're like oxygen. So when they go, there's an outage, or when they go silent, it brings the businesses to a grinding halt. Now, how does Google fare in this area? So this is a Forrester report This is for infrastructure as a service, platform native security, and it's fairly recent. It's from Q2 2023. And you can see Google has been given a leadership position, and specifically when it comes to strategy. So the reason Google does so well in core native infrastructure security is because the entire stack of Google Cloud is purpose-built. It starts all the way from physical security of the data centers, including some of the matrixy things like laser beams on the data center floors, to custom-built hardened chips and servers. So we strip down our hardware to the bare minimum so we can reduce our attack surface, to all the way to encryption at rest, encryption in transit, and now with confidential computing, even encryption in use. So because of all of this, Google has been given this position in the Forrester report. Coming to the second thing of why customers use cloud, it is to build their digital offering, which is to develop software on the cloud. Now, cyber attacks on CI/CD pipelines can lead to supply chain compromises. We'll look at two examples here. The one on the left took place a few months ago, and this is the first time where we saw something we're calling a cascading supply chain attack. So what essentially happened was an attacker got into an organization. He implanted a poison update onto their website. Someone at c0c0n Softwares, which is basically they make communication softwares, they downloaded this update. Through this downloaded software, the threat actor now had access to c0c0n networks. And once in, he did the exact same thing. He compromised the supply chain. He hacked the build system and implanted poison update in c0c0n software itself. Now, when that happened, and when this software was distributed to all of the c0c0n customers, the threat actor reached all of their premises as well. The threat actor turned out to be a North Korea state-sponsored actor at the end of the day. But situations like this can be nightmares for organizations. They obviously become very public. They obviously not only affect them, but their customers as well. Another most notable example, and I'm sure everyone's heard of it, is the SolarWinds supply chain attack that happened. And in this case, the actor went to great efforts to make sure that the compromise remains hidden. Thousands of organizations were affected by it, and almost it went undetected in all of them. So it becomes very important to secure your CI/CD pipelines on the cloud so as to not introduce supply chain compromises. Let's see how Google fares in this area. So this is, again, Forrester Wave report for cloud-native CI tools. Google Cloud is in the leadership position both in the strongest current offering as well as in strongest strategy. Now, this is because Google knows how to build software and it knows how to build them securely. And when through Google Cloud, we are essentially sharing those best practices through managed offerings with our customers. In fact, we have an end-to-end managed solution. It's called Software Delivery Shield. So this is an end-to-end managed solution for securing your supply chain. It takes care of all the phases of the software development lifecycle. So when it comes to development, we have secure workstations on the cloud. We have something called as cloud code, which can tell you that if a dependency you're using in the cloud has known vulnerabilities and warn you against using it, all the way to securing the supply, which is through something called as Assured OSS. So Assured OSS is open source software packages that have been vetted by Google. So when you reference those Python and Java packages in your code, you can be reasonably sure that they have not been compromised. Similarly, for CI/CD, our CI managed offering is called Cloud Build. And Cloud Build now comes with inbuilt SALSA level 3 provenance. So the best practices are inbuilt from day zero. Similarly, our CI/CD pipeline is called Cloud Deploy, and that has inbuilt security features as well. One of the most used runtimes, container runtimes for us are GKE and Cloud Run. And they have baked in security to ensure you get real-time threat, config threat detections, you get misconfig detections, etc. But apart from just the 4 stages of the software development lifecycle, there is also a central trust-based policy engine. So So what this trust-based policy engine establishes is trust between different components of the cycle. So you establish trust, you maintain trust, and then you verify trust. There's something called as binary authorization, which is a runtime security tool, which can make sure that the software you're deploying is authorized. So your DevOps teams and your security teams can essentially go to a trusted party, ask them to sign a certain version of the software, and at deploy time enforce that only that software is deployed. So let's look at how Google does in this area. Again, this is Forrester Wave for cloud native continuous integration tools, and I am in the wrong slide. Yep. So we're moving on to the third area where customers use cloud, and that is to interconnect with partners. Now, even in this area, the cyber attacks on APIs can lead to data leakages of PII of your customer informations. So we're looking at two examples on the slide. The first one is in the US, and both of these are telco examples, where 37 billion mobile customers' PII information was leaked. Closer home in Australia, we saw 11 million telco breach happen, and that led to a data leak. So what happens when you become more digitally transformed is your environment becomes more agile, it becomes more dynamic. It's virtually impossible for the IT teams and security teams to keep a tab on what's existing in your environment. And therefore, it becomes important to monitor your attack surface as well as keep a tight control on your APIs. When it comes to Google, we have a solution called Apigee. Apigee gives Google Cloud very strong API management and API security capabilities. So if you look here, Google is the only hyperscaler available in the leadership quadrant. There are other niche players there, obviously. But APIs are so fundamental to the cloud that we've invested focus and we've invested resources into making it happen. Coming to the fourth area where customers use cloud, it's to serve their end customers. Now, cyber attacks on the end customers are tricky because these attacks are not flowing through an infrastructure of the organizations themselves. So think of email-based attacks, think of phishing attacks. But it is important to prevent these attacks because they can make their way back to your backend microservices, which you must be hosting on containers, etc. So I'm sure many of you are Chrome browser users here. And you might have noticed that sometimes when you input your password, it tells you that this password is in a known leaked breached list and asks you to change your password. Now this capability, the organizations can extend to their end customers in their apps as well through reCAPTCHA. So let's say you have your own application in which an end user is inputting the username and password. You can hash that password. You can send it through an API to reCAPTCHA endpoint and ask whether this password is in a known, leaked, and compromised list. And if the answer comes back yes, then you control how the passwords are monitored in your app, so you can enforce a password reset or add additional questions to it, etc. So that's one of the things that reCAPTCHA does. So this is a Gartner peer review on online fraud detection. So this is essentially feedback from a customer organization who have used reCAPTCHA, and they said that it has brought them great success and it has helped them identify passwords that have been compromised, essentially what we talked about. But reCAPTCHA does a lot more than that. But somehow, whenever we think of reCAPTCHA, we think of anti-bot protection. We think of those 9 annoying grids where we are asked to choose fire hydrants and trucks and whatnot. But that was reCAPTCHA in 2016. The current version of reCAPTCHA has no visible interface with the customer. It's all invisible and transparent. And it does a lot more than just bot detection. It does have multi-layered protections for account takeover protection. So there's something called as an account defender that does behavior analysis on a credential set. So say I have logged into an app with a username and password. It tries to find out whether it's a legitimate access or whether it's an imposter who has gotten the access to these credentials. So this is a very creative way where they map how I work, so it requires a lot of telemetry, a lot of signals, and then it comes up with a risk factor. So if the risk factor is high, you can essentially redirect to more security questions, or you can redirect it to a password change, etc. So these were some of the ways in which customers use cloud. Now let's talk about actual differentiation. What makes Google Cloud Security different? We'll explore this through 3 key pillars. The first one is outcomes. So you can use Google Cloud Security and you can reach different places. We'll see what these places are. Second is security intelligence and experience. We all know that cybersecurity cannot be achieved with technology alone. It has to be accompanied by people, it has to be accompanied by process. And we'll see how we fare in that area. And lastly, to do security right, it has to be in your DNA as a core competency. Security cannot be a side gig. We'll see how Google fares in this area in terms of how Google has security as a core competency. So we'll start with outcomes. We talk to a lot of customers every day. Very few have the outcomes that I'm about to discuss, but most of them want to achieve that. So through Google Cloud, this can be a reality. We have managed solutions available to help them reach there, because we enjoy these outcomes internally, and we want to help our customers in this journey as well. So the first outcome at Google is we have no more VPNs. VPNs came about in 1996, and they continue to cause havoc even today. So this c0c0n 3661 is a very low sophistication actor, and he uses VPN credentials to break into networks. The APT28 is a nation-sponsored threat actor, so highly sophisticated, very capable, and they used VPN to target as well. So both ends of the spectrum are still targeting VPN. In security, it is very rare to say that we've completely managed risk. At best, we can reduce risk. We cannot eliminate risk. But at Google, we've managed to completely eliminate VPN-based risks. And the whole way of doing that is to replace VPN with something else. So at Google, we've done away with this fortress VPN architecture and essentially brought in a zero-trust architecture. So in my 3 years at Google, I've logged into a VPN exactly 0 times. This architecture is real, it's functional, and it drives a much better end-user experience, but also ensures more security. Another outcome we enjoy at Google is more difficult post-exploitation. So post-exploitation starts when an intruder has entered your network, and now they'll start doing recon of your network, they'll start moving laterally, they'll start to gather credentials, and they'll eventually complete their mission. Majority of this post-exploitation is moving laterally within trusted zones, between trusted networks. In Google architecture, we have no trusted network. Everything is zero trust. So it becomes very difficult for a threat actor to move laterally in our architecture. So then how do we do it? We have moved away from access to services, which is purely based on the network from which they connect. The access to service is granted based on identity and other contextual factors, such as which device the end user is using. And every access between every service has to be authenticated, authorized, and encrypted. Another interesting outcome here at Google is no more password changes. You have one password on the day you start working at Google, and that's it. Now, there are some constraints. You're not allowed to use that password for anything else other than Google, but there is no rotation, periodic updates to the employee passwords here. And in security, there's always this balance that we try to achieve between convenience and security. And mostly, more convenience means less secure, and less convenience means more secure. But this sort of gave us the best of both worlds. So yeah, I've had the same password in 3 years. Last outcome I'm going to talk about is the investigations that result in answers. But before that, Mandiant is now a part of Google Cloud Security ecosystem, And if you don't know, Mandiant is a cybersecurity firm. They're most known for responding to incidents. So if you see a headline incident, it's most likely that Mandiant is tasked with coming there and helping them respond and recover. So when Mandiant reaches a crime scene, when they reach a victim organization, they're often asked a business question: what all has been stolen from me? And to answer that question, they need certain types of logs. Often the reply that they get is, because that certain log type was so voluminous, and we were constrained by cost, and we were constrained by capacity of our SIEM systems, that we decided to downscale that log type. And now to answer the question, what was stolen from us, becomes even more difficult. It can be incredibly frustrating to spend a lot of time, effort, money, human hours into creating a security infrastructure, only when the time comes to not be able to find the answers. So Google has a security operations systems called Chronicle. This is our SIM and SOAR. And it's essentially based on the same backend that power Google Search and YouTube. So scale and cost are not a constraint for us. So the decision to downscale telemetry is not needed to be made when you're using Chronicle. That helps you get the right answers when you are under investigation. Second bucket of differentiation we have is intel and expertise. So cybersecurity alone cannot be achieved with technology. It has to be accompanied by people and processes. So as I said, we have Mandiant as a part of Google ecosystem now, and Mandiant is the most trusted name when it comes to incident response. And if we are talking about response to state-sponsored threat, that's doubly true. They respond to 18,000 incident responses in a year. And if you look at the Forrester report for incident response services, we'll see Mandiant as the strongest leader. No other hyperscaler is even present here. There is a derivative effect to incident response, and that is threat intelligence. You gather deep knowledge about how a threat actor operates. You understand their tools, you understand their techniques, you understand their procedures. And that can be a very effective way to lead security through intelligence. So again, we are looking at a Forrester report on external threat intelligence service, and we see Google in the leadership quadrant. No other hyperscaler is present there. Now, when you combine Mandiant's curated threat intelligence with VirusTotal, which is the world's largest malware observatory, you have very powerful threat intelligence. So you have a crowdsourced threat intelligence combined with curated threat intelligence, and that's very difficult to beat. So this combination gives us a deep understanding of threats, and it gives us a deep understanding of how to elevate the security postures of organizations. The last pillar of our differentiation is security in our DNA. So Google has been very aggressive when it comes to innovation in cybersecurity. We have had a long history of innovation. The most notable one was the passkeys, which has happened this year, and we hope to have a passwordless future with this. Another important aspect to consider when considering the security DNA at Google is scale. Google services and products touch billions of users every day. The ability to secure our systems and our end users at that scale is in itself a great accomplishment, because we have to be hyper effective with our security. The scale at which we operate is larger than most organizations out there. So even a small fraction of false positives or a small fraction of undetected attacks is a very large absolute number. Another way we show that security is in our DNA is we back our intent with investments. We show commitment. So Google has committed $10 billion for the advancements of cybersecurity. And Google has the resources. Okay. And Google has the resources to take on the tough challenges that we see here, right? It has the resources to challenge how we do security, to re-architect a lot of things, to change the battleground. For example, how we moved from VPN to a zero trust architecture. So there are other security differentiators, which I would briefly touch on as well. First, the most prevalent attack on cloud infrastructure is crypto hacking. So in crypto hacking, an intruder would intrude into your cloud infra. They would set up resources, and then they would start mining things like Bitcoin. And then they hope that you never find out that these resources are up and running till your next bill. And then you're invoiced for all these resources. So Google has great confidence in its ability to defend against these types of attack. And we give a $1 million USD credit guarantee if you follow our best practices. The way we achieve this is through something called as a VM threat detection system, which is part of our security command center. And this sits at a hypervisor level. So it will look into your guest operating system, it will look into the memory, and look for signs of a crypto hacking attack. You do not need to install any agent, and this essentially the platform, the underlying architecture is taking care of this on its own. And of course, no cybersecurity without data security. So we have Google Workspace, which is our collaboration. We have Google BeyondCorp, which is our zero trust architecture as an enterprise solution. And we have Chrome, which is our enterprise-grade browser. And all of these combined place us, when it comes to data security, very high up in the Forrester wave. I would end because I've been given a time constraint, so we might not have time to go through the AI intersections with security, but I would wrap with this. So there are customers who extend Google securities to their endpoints through Chrome OS devices. Now, Chrome OS devices do most of their things on cloud, which allows them to have very thin endpoints. And thinner the endpoints you have, you essentially reduce your attack surface. And when you reduce your attack surface, you're already more architecturally secure. Thanks to a lot of other inbuilt security capabilities, as well as more defense, there have been 0 reported ransomware attacks on any of the businesses, on any of the educational institutes, or on any of the consumers that consume Chrome OS. Thank you very much. I hope this was useful.